Assalamualaikum and hello, my name is Nur Naziefah Binti Zukarmi. My matric number is CN190200 and from section 1. My title is Generation in Solar. So this is one of the example of the solar. Concept solar. First, radiation from the sun capable of producing heat, causing chemical reaction or generating electricity. The sun is a source of energy we use to generate electricity. This is called solar power. Definition of solar is the conversion of energy from the sunlight into electricity, either directly using photovoltaic, which is PV material, indirectly using concentrated solar power or a combination. Concentrated solar power system use lens or mirror and solar tracking system to focus a large area of sunlight into a small beam. So next is basic structure of PV solar cell. So this is the basic structure of PV solar cell. So the orange color is P-type. The green color is N-type. So this is the N-type semiconductor, and this is the P-type of semiconductor. The white color of the bottom is conductive contact. So this is for white, and the purple of the top is conductive grip. Conductive grip or transparent conductive film. So for this is blocking the electrode. Blocking the electrode. In a PV cell, the absorbed photon energy generates electron hole pairs that become a source of electricity. Electrons flow to the positive side of the load and hole flow to the negative side of the load. Then, in PN junction solar cell, a bulk potential is the major driving force. The difference in work function of two contacts could be another driving force in charge separation. Characteristic. So this is the solar cell component and layers. First, there are many different components and layers and we'll become familiar with the properties. The purpose of all these layers throughout the course. Then, a solar cell can take energy from illumination and convert it into electrical energy in an external circuit. Characteristics of solar cell have six. First, open circuit voltage. Second, short circuit voltage, shunt resistor, series resistance, internal quantum efficiency, and last one is external quantum efficiency. First, we go to open circuit voltage, VOC. First, in an ideal solar cell is independent of the illumination intensity. Maximum voltage generated across the terminals of a solar when they are kept open. Then, the open circuit voltage depends on the light generated current and the reverse saturation current. Material having large band gap have higher. Second is short circuit voltage, ISC. Short circuit current is the maximum current produced by a solar cell when its terminals are short circuit. Then, when a photon is absorbed in a solar cell, it generates an electron hole pair which separate by a junction and then transform to the external circuit. For maximum short circuit current, we have to assume that there is no recombination in the material. A filter is required to process energy higher than the band gap energy of the material in order to be absorbed. A material with a large band gap will absorb less number of photons as compared to the material with low band gap. Characteristic of resistance. The characteristic resistance of a solar cell is the output resistance of the solar cell at its maximum power point. Then, if the resistance of the load is equal to the characteristic resistance of the solar cell, then the maximum power is transferred to the load and the solar cell operates at its maximum power point. Next is shunt resistance. Represent any parallel high conductivity band which is shunt across the solar cell, PN junction or on the cell edge. These are due to crystal damage and impurities in and near the junction and give rise to the shunt current. Effect of shunt resistance. Low shunt resistance causes power losses in a solar cell by providing an alternate current path for the light generate current. Such a deviation reduces the amount of current flowing through the solar cell junction and reduces the voltage from the solar cell. Then, the effect of a shunt resistance is particularly serious at low light levels, since there will be less light generated current at lower voltage where the effective resistance of the solar cell is high. The impact of a resistance in parallel is large. Series resistance. Series resistance of a PV module represent resistance in cell solder bonds, armature and base regions, cell metallization, cell interconnect, byte bars, and resistance in junction box termination. Then we go to effect of series resistance. Therefore, evidence that a small increase in Rs can be detrimental to the performance of PV module due to the power loss. The current voltage measurement can be used to quantitatively evaluate increase in Rs. These measurements are also sensitive to change in module shunt resistor and other cell parameters. What is quantum efficiency? The formula is quantum efficiency is number of carriers collected by a solar cell divided by number of photons of a given energy incident on a solar cell. What is quantum efficiency? The others. All photons of certain wavelength are absorbed. Efficiency is unity of that wavelength. For energy below wavelength is called zero. Quantum efficiency have two, internal and external. So we go to internal quantum efficiency first, which is after optical loss, absorb photons which can generate collectible carriers. Then external quantum efficiency. What means external quantum efficiency? By surface texturing, this can be improved, and for organic cell, efficiency is high. How it works. How solar panel convert solar energy to electrical energy. First, each silicon atom is connected to its neighbors by 4 strong bonds which keep the electron in place so no current can flow. Second, a silicon solar cell uses 2 different layers of silicon. As we can see, this is the layer of N and this is the layer of P. So this is the 2 layers of silicon. Third, an N-type silicon has extra electron and P-type silicon has an extra space for electron cold hole. So the P is cold holes because P-type silicon has an extra space for electron and type silicon has an extra electron. Then when the two types of silicon meet, electron can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the others. So N will be negative charge and P will be positive charge. The light as the flow of tiny particles is called photons shooting out of the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now moved to 3 around. But because of the electric field at the PN junction, they will only go one way. The electron is drawn to the N side, while the hole is drawn to the P side. Lastly, electrons are the only moving parts in a solar cell, and they all go back where they came from. Advantages for solar cell. First, free and cause no greenhouse gas to be emitted after installation. Then, reduce dependence on foreign oil and fossil fuels. In addition, efficiency is always improving to the same size solar that is available, which is available today will become more efficient tomorrow. Then create jobs by employing solar panels manufacturers, solar installers, and it in turn help the economy. Ability to live grid-free if all power generated provide enough for the home or building. Then can be installed anywhere such as field on a building. Then solar cell use batteries to store extra power used at night. Can be used to heat water, power homes and buildings. Then solar cell is the safe than traditional electric current. Lastly is return on investment unlike paying for alternative bill, and this can be saving the money. But solar cell has not only have advantages, but solar cell has disadvantages too. What is disadvantages for solar cell? First, need a lot of space as efficiency, not 100% yet. Then, solar production of solar is lower in the winter month. High initial cost for material and installation for long reduction of costing. No solar power at night and need a large battery tank. Cloudy days not produce as much energy. Solar panels are not being mass-produced due to lack of material and technology to lower the cost enough to be more affordable. Then, the solar cell disadvantages is the device run on DC power directly are more expensive. Depending on geographical location of the solar panel, solar power cars are not having the same speed and power as typical gas. Then, solar production of solar is lower in the winter month, which means like the rain of the day. So that's all from me. Thank you.